Okay, so today we're going to talk about the last of our four conics. Again, we've seen a circle, we've seen an ellipse, and we saw a parabola. Today we're going to talk about a hyperbola. A hyperbola kind of looks like a parabola with two of them. Okay, we have our horizontal one over here on the left where they open up horizontally to the left and right in this case. And on the right side, we have our vertical one that opens up and down. You'll notice the equations are very similar down here to an ellipse, except for you'll see a minus sign in there instead of a plus sign. You'll also notice that x and y can switch places. So whichever one's in front, okay, the one that's in front of the minus sign, in this case the x, that tells us we're going horizontal, y means we're going vertical. Also, A does not change spots. A is first, B is second, and so forth. Okay, so it used to matter which one is larger. It does not matter in this case. Okay, and because we're using C squared is actually equal to A squared plus B squared. So we look at the images here. Okay. Whichever one comes first, so in this case x is first, A is telling us how to get to our vertices. So going out to our vertex. Okay. And then from the center plus your C in the horizontal direction gets you to your focus. Now, to draw in these images, you have to find these two asymptotes. And that's where the B comes pretty important here. Okay, if we're dealing with a horizontal hyperbola, to graph those asymptotes, it's y equals plus or minus b over ax. And then if we're going vertical, you'll notice we go up a and right b. So it's actually y equals plus or minus a over bx. Okay, and those are important because they help us graph. Once we know our vertex, we know, okay, we got to head towards those asymptotes. The other thing you see is this box here. Okay, this box is not actually part of the graph, but it's nice to draw it in a lot of times. You'll notice that this box has a height of 2a in this case. On the left side, that would have a height of 2b. On the right side, a width of 2b. And on the left side, a width of 2a. Those are two axes. So you have a transverse axis, which is the one going up or down. And then you have a conjugate axis, which is the one going left to right. And from time to time, you may be asked, what is the length of the transverse or what is the length of the conjugate? And those are important because they deal with our A and our B. So if someone told you, oh, the length of this hyperbola's conjugate axis is 8, you would know that B is 4. And that can help you get to making your equations. Okay, so let's look at our first graph here. Just to understand, a hyperbola is defined as the set of all points in a plane that are the difference, okay, the distances from two fixed points is constant when I take the absolute value. So any 2 points I pick, okay, if I were to pick this point here, the difference to go to one focus to the other, okay, which in subtraction anyway, just take the absolute value, would be the same as from this point's difference of going from this focus to this focus. Okay, nothing you have to worry about too much here. It's just the idea of where does the focus come from in this case. So our first one, we see that x is first. That means we're going to go horizontal. Let's figure out where our center is at. And it's at 0, 0. Your A is always first. Your A is 5. B is 7. Then we can go find our C squared. Sometimes it's nice just to find these all right away. That's adding them together. So C is the square root of 74, which is about 8.6. Now, since we're going left and right, our transverse axis comes from the A equals 5. It means we're going left 5 and right 5. So that's, in this case, our transverse axis has a length of 10. Your B is telling us up and down, our conjugate axis. And what sometimes you'll see is some people draw in a box like this. And now, for our asymptotes, when we were talking about that distance there, your asymptote, remember it's supposed to be y equals, in this case, going up b, so plus or minus b over a would be 7 over 5. Well, that's just telling you to go towards those corners. So we're actually going out through those corners. So sometimes it makes it a little bit easier to follow that route. And then graphing gets easier for you. Okay, so if you follow the slope there, that'd been up 7, right 5. Okay. And then our focus, okay, since we're going left and right, it is going to be adding it to A. So it'd be 5 plus or minus, oops, sorry, we're at 0, 0. So we're going to go, it's just going to be going from your center, which was 0, and going out square root of 74 both directions. So it'd be plus or minus the square root of 74 comma 0, which is about 8.6. So that's going to get us 7, 1, 2, 3, 4, 5, 6, 7, 8. So get us up to here. That's going to be our C's, our foci. Okay, and then it's a sketch. And we want to go out towards the asymptotes. And there we go. So we want to talk about the length of our axes. The transverse axis had that length of 2a, so in that case 10, and the conjugate had a length of 14, going from top to bottom. All right, so here we're going to have to divide by 100 first to get going. We get y squared over 4 minus x squared over 25 equals 1. So that makes a is 2, b is 5, and we go right ahead and get our c. Because c squared equals a squared plus b squared. C equals the square root of 29, which is about 5.4. Now remember, since y is first, we are going to go up and down. We have a vertical hyperbola, center at 0, 0, so we have no moves there. And we got to be careful now. A is up and down this time. So we're going up 2 and down 2. That's our transverse axis. It only has a length of 4 this time. And then B, left 5 and right 5. Okay, you can draw in a little box there. That might help you a little bit. Okay, so we know that's going to help us out with our asymptotes. Because this time our asymptotes are actually going to be plus or minus A over BX. So 2 over 5. Asymptotes are actually going to go like this. And then our focus, which is being added to our y value this time, would be 0, comma, plus or minus the square root of 29. Then we can go in and draw our hyperbolas. And there we go. In this case, we had a conjugate axis of 10, a transverse axis length of 4. So again, it's transverse is always vertex to vertex, conjugate is going the other direction. Okay, our final problem here, we notice that we have y in front, so we will end up with a vertical hyperbola again. Okay, this time it will be centered. at -2 or -3, -2. Be careful, X is first, then Y, even if they get flipped on that order. So -3, -2. Okay, in our vertical direction, okay, we see there we have a squared is 9. That means a is 3, so we're going to go up 3 and down 3. Those are going to be your vertices there. B is squared is 4, so B is 2. So we're going to go left 2 and right 2. And what we can do here is we're going to form a little box to help us out. We can already now go in and draw in our asymptotes. Our asymptotes are going to go through the corners of these boxes. Okay, you do not need to worry about writing the equation for an asymptote here at all. And this is perfectly fine. And we can actually go and draw our graph already. We know our graph is going to have our vertices at the top and bottom here, and they're going to go and approach our asymptotes that we have drawn in. The only thing that we are missing is where our foci are. So we can go figure out what c squared is. Remember that's equal to a squared plus b squared. So c squared equals 13. C is the square root of 13. Square root of 13 is about 3.6. Okay. So from our center, okay, which was -3, -2, our foci will become -3 is going to stay the same. We're going to be going up and down, -2 plus or minus the square root of 13. Go down just over 3. Foci are going to be here, and the other foci is going to be right about here. Okay, that does it.